Today's video will be on area of special quadrilaterals. Okay, so our learning goals for today: by the end of the lesson you'll be able to calculate the area of parallelograms, calculate the area of rhombuses, calculate the area of trapeziums, calculate the area of circles, and calculate the area of sectors. Okay, so on this page here we've got three different shapes. The first is what we call a parallelogram. So you'll notice on a parallelogram it'll have two sides that are parallel. Those arrows show that they're parallel, and the number of arrows just shows you which side it aligns with. So the top two sides are parallel, and on the edges here you'll see again it's got these two arrows saying these two sides are also parallel, hence the name parallelogram. You'll also see you're given a height value, so again that dotted line and then a right angle with a value will be the height, and the base value, which will be the area from one corner to the other. So to work out the area of a parallelogram you do base times height. So in the middle here we have a trapezium. So you see the trapezium again has two parallel sides. Now with these parallel sides, one will be called A and one will be called B, and that'll be the distance from each, across that side. So that one's B, and from this line to this line will be A. And you'll also be given a value of the height, which is the kind of the distance between A and B. So to work out the area of a trapezium, you do a half in brackets A plus B. So the reason we do this is because with our order of operations, brackets means we have to do that first. So you add A and B together, and then you do a half times that, the sum of A and B, and times that by the height. The next one here is a rhombus. So you'll see it's got the markings that show all of the sides on a rhombus are the same length. So it's kind of like a pushed over cube, I guess, because all the sides there are the same length. And you'll also be given an X and a Y value, which are the values from corner to corner. And to work out a rhombus, the area is a half X times Y. Okay, so three more shapes here. We've also got a kite, which looks like a kite. So the kite will have two sides that are the same length, and they will meet together at a point, and another two sides that are the same length, and again they'll meet together at a point as well. You're also given an X and a Y value. So X value here is like the distance from the widest part across, so I guess across the widest parts, and a Y value which is kind of the longest part, the height of it. And your area there is a half X times Y. So very similar there to what we had for the rhombus. In the middle we've got a circle, and a circle, the area is pi r squared. So that's pi, which remember was 3.14159, etc., which we'll use our calculator for, times the radius, which is the line from the center out to the outside of the circle, squared. And then we have a sector. So a sector is like part of a circle there. So to work out the area of a sector, it's similar to the area of a circle, just a little bit different. So because it's not a full circle, you will be given an angle here. So to work out the area, you do that angle that you're given over 360, because the whole way around a circle is 360 degrees, but we only want part of the circle. So you do that part, whatever that angle is, divided by 360 times pi r squared, and either of these sides here will be r because they're going from the edge of the circle to the center. So you'll be given one of those values as well. Okay, so we've got some worked examples here. The first one is a circle. So to work out the area of a circle, we'll always start with our formula. So area of a circle equals pi r squared. So in this case it's pi times 5.1 squared. So pi times 5.1 squared is 5.1 times 5.1. It's 26.01. So in our calculators we can do pi times 26.01, and that will give us 81.712824, etc., and we're always going to round to two decimal places unless we're told otherwise. So 81.712 we'll just round to 81.71 centimeters. Now for B we have got a sector. So remember, a sector is just part of a circle. So to calculate the area of a sector, we're going to do the degree that we're given over the total, which would be 360 degrees, times our usual formula for a circle, which is pi r squared. So in this case, we're given 260 degrees, because from here all the way around is 260. So that's 260 divided by 360 times pi times r, which is 4 meters, so 4 squared. So 260 divided by 360 is 0.72 reoccurring times pi times 4, which is 16. So we can type that into our calculators. C times pi times 16. And it gives us an answer of 36.30284, etc. Again, we're going to round to 2 decimal places. Also, I forgot my squared up there. Sorry. So 36.302 rounds to 36.3. And I'm going to write my units, meters squared. Please don't forget to write your units in squared. I did forget on A. Don't forget to do that. So for C, what shape do we have here? So we've got these two sides are parallel, and this side here is also parallel. So this is going to be a parallelogram. So our area of a parallelogram is our base times our height. So our base is 3 centimeters and our height is 1.5 centimeters. So 3 times 1.5, what's that, 4.5? I should know this. Yep, good, just checking. 4.5 centimeters, and because we're doing area, squared, and that would be our answer there. Okay, for our next one, we've got 2 more of these special quadrilaterals. So for our first one, we're given all these sides. So all of these sides are the same length, and these 2 are parallel, and these 2 are parallel. So if we look at that, hopefully you remember that we've got a rhombus. So the area of a rhombus is going to be a half x times y. So we're given our values of x and y here. So it's 1/2 times 10 times 9. So a half times 10 is 5 times 9 is 45 millimeters squared. That would be our area there. Now for B, so with B, looking at this shape, you can see we've got parallel sides here, and we're given a height. Sorry. So hopefully you realize that's a trapezium, and the area of a trapezium is a half, A plus B in brackets, a half times A plus B times our height. So you can fill that in. So it's 1/2 A plus B, so 6 plus 4 times our height. There should be a times here, times our height, which is 3. So that's 1/2 times 10 times 3. 1/2 times 10 is 5. 5 times 3 is 15 meters squared. And that's our area there for that one. Okay, so our last example here is find the perimeter and area of this composite shape, rounding answers to 2 decimal places. So a composite shape is obviously a shape that's made up of more than one simple shape. So if we look at this one, we have a rectangle and a semicircle, so half of a circle there. So the first thing it wants us to do is calculate the perimeter, and the perimeter is the sum of all sides. So we just have to add all the sides together. So up the top there we've got 17 centimeters, and we can see that it's got the same markings as the bottom line there, so that one must also be 17. On the side here we've got 14 centimeters. Now we're not going to add 14 again because we're trying to find the perimeter, and on this side we actually have half of a circle. So what we're going to do is do the formula of a circle, the circumference of a circle divided in half. So we're going to half of a circle, which is pi times the diameter, and we know our diameter here because it's the same as the 14, so it's a half pi times the diameter, which was 14. So using our order of operations there, we know we have to do multiplication first, so it's still going to be 17 plus 14 plus a half times pi times 14 equals 21.991148. We're going to round to 2 decimal places. So 21.9911 rounds to 21. So 21.991 rounds to 21.99. Add that all together. 18 plus 17. It's 69.9911. So again, we're just going to round to 2 decimal places. 69.99. And won't forget our units. So that'll be perimeter of that shape. So that's the outside there. And now it's also asking us to work out the area. So I'm just going to clear this. So I've got a clean slate. So the area, we've kind of got 2 different shapes. So using this dotted line, we've got a rectangle here. So we're going to find the area of this rectangle. And then we also have to add on the area of this half of a circle here. Now, to do this, we're going to do the area. Actually, I'll write down the page a little bit. So area equals the area of our rectangle plus half the area of a circle, or you could do the area of a vector. Because it's half of a circle there, you could do 180 degrees plus the area of our semicircle. That's a terrible semicircle, but you get the point. So area of a rectangle is length times width plus the area of that vector, which is the degrees, divided by 360 times pi r squared. Or you could do area of a circle, which is pi r squared, and divide that by 2. Either way would be correct. You'd still get the same answer. So length times width, we've got 17 times 14. Plus, because it's half a circle, it's going to be half of 360, which is 180. 360 times pi times r. So our radius is only part of this way. So our radius is going to be 14, divided by 2, which is 7 squared. Okay. So putting that into our calculators, obviously with our order of operations, we're going to do the 17 squared first, which is going to be 14. So 17 times 14, so the area of our rectangle there is 238 plus 0 and times 49. So our area of our semicircle is 76.969020001. We're going to round that. So 76.969 rounds to 76.97. So we're rounding that up. Add that to our area of our rectangle. And our answer is 0.97. So 314.97 centimeters squared, because we're dealing with area there. And that's the end of the video. Any questions at all, make sure you come and ask me.